Hey there, AI enthusiasts! Welcome back to Learn AI with me. I'm your host, Manoj, and today we're diving into a topic that's all around us but often goes unnoticed: natural language processing, or NLP for short. Let me ask you something. Have you ever used Google Translate to understand a foreign language? Or asked Siri or Alexa to play your favorite song? Or maybe you've chatted with a customer service bot that actually made sense. If you've done any of these, you've already experienced the magic of NLP. I remember the first time I used Google Translate on a trip abroad. I was in a small cafe, staring at a menu written entirely in a language I didn't understand. I typed a few words into the app, and within seconds, it translated the menu for me. It felt like I had a personal interpreter in my pocket. But how do machines understand something as complex and messy as human language? And how did we get to this point where machines can hold conversations, translate languages, and even write essays? That's what we're going to explore today. We'll start with the basics of what NLP is, take a journey through its fascinating history, and then dive into its real-world applications, challenges, and the exciting future of this technology. So grab your favorite drink, get comfortable, and let's dive into the world of NLP. What is natural language processing? All right, so what exactly is NLP? At its core, NLP is a branch of artificial intelligence that focuses on enabling machines to understand, interpret, and even generate human language. It's what allows your phone to autocorrect your texts, your email to filter out spam, and your favorite apps to recommend content based on what you've written or said. But here's the thing: human language is incredibly complex. We have slang, idioms, sarcasm, and even words that mean different things depending on the context. For example, think about the word bank. Are we talking about a riverbank or a financial institution? Machines need to figure that out, and that's where NLP comes in. To make sense of language, NLP combines two key areas. 1. Linguistics, the study of language including grammar, syntax, and semantics. 2. Machine learning algorithms that help machines learn patterns in data, like recognizing the structure of a sentence or the meaning of a word. Together, these fields allow machines to process and understand text and speech in ways that feel natural to us. History and evolution of NLP. Now, let's take a step back and look at how NLP has evolved over the years. It's been a long journey, full of breakthroughs and challenges. 1950s. The birth of NLP's roots go back to the 1950s, when Alan Turing proposed the famous Turing test to measure a machine's ability to exhibit intelligent behavior. Around the same time, researchers started experimenting with rule-based systems to process language. One of the earliest NLP programs was ELIZA, created in the 1960s. ELIZA was a chatbot that mimicked a psychotherapist by responding to user input with simple rule-based replies. For example, if you said, "I feel sad," ELIZA might respond, "Why do you feel sad?" It wasn't very smart, but it was groundbreaking for its time. 1970s, 1980s, rule-based systems. During this period, NLP relied heavily on rule-based systems, where linguists manually wrote rules for grammar and syntax. These systems worked well for specific tasks, like translating simple sentences, but they struggled with the complexity and ambiguity of real-world language. For example, early translation systems could handle basic phrases like, "I am hungry," but they would fail with idioms like, "I'm starving," which means the same thing but uses different words. 1990s. The rise of statistical NLP. In the 1990s, NLP took a big leap forward with the introduction of statistical methods. Instead of relying on handwritten rules, researchers started using large data sets and probability models to analyze language. For example, hidden Markov models, HMMs, were used for tasks like speech recognition and part-of-speech tagging. This shift made NLP more flexible and scalable. A great example of this era is Dragon Naturally Speaking, one of the first commercial speech recognition tools. It wasn't perfect, but it paved the way for the voice assistants we use today. 2010s, the deep learning revolution. The 2010s marked a turning point for NLP with the rise of deep learning. Neural networks, especially recurrent neural networks, RNNs, and long short-term memory, LSTM networks, allowed machines to process sequential data like text and speech more effectively. In 2018, the introduction of the transformer architecture revolutionized NLP. Transformers, like the ones used in BERT and GPT, made it possible to process entire sentences or paragraphs at once, rather than word by word. This led to huge improvements in tasks like translation, summarization, and text generation. Present-day, large language models. Today, NLP is dominated by large language models like GPT-3, which can write essays, answer questions, and even hold conversations. These models are trained on massive amounts of text data and can perform a wide range of language tasks with impressive accuracy. For example, GPT-3 powers tools like Jasper AI, which helps businesses write marketing content, and ChatGPT, which can assist with everything from coding to creative writing. From simple rule-based systems to powerful deep learning models, NLP has come a long way. And the best part? We're just getting started. How does NLP work? Now that we've explored the history of NLP, let's break down how it actually works. NLP involves several steps, and each one helps machines get closer to understanding human language. Here's a simplified version. Text pre-processing. This is like cleaning up the data. Machines remove unnecessary parts like punctuation, convert everything to lowercase, and even break sentences into individual words. For example, the sentence "I love AI" becomes "I love I." Tokenization. This step breaks text into smaller pieces like words or phrases so the machine can analyze them. Think of it as chopping a big puzzle into smaller pieces. Part of speech tagging machines identify the role of each word in a sentence, like whether it's a noun, verb, or adjective. For example, in "the cat sleeps," cat is a noun, and sleeps is a verb. Named entity recognition, NER. This step helps machines identify specific names, places, or dates in text. For example, in Elon Musk founded SpaceX in 2002, the machine recognizes Elon Musk as a person, SpaceX as an organization, and 2002 as a date. Sentiment analysis. Machines analyze the tone of a sentence, whether it's positive, negative, or neutral. For example, "I love this movie" is positive, while "this movie is terrible" is negative. Language modeling. This is where deep learning comes in. Models like GPT-3 and BERT learn to predict the next word in a sentence or even generate entire paragraphs. For example, if I say, "The weather is," the model might predict "nice today" or "cold and rainy." These steps work together to help machines understand and respond to human language. It's like teaching a machine to read, listen, and even talk. Real-world applications of NLP. Now that we know how NLP works, let's talk about where it's being used in the real world. Spoiler alert, it's everywhere. Voice assistants, Siri, Alexa, and Google Assistant use NLP to understand your commands and respond intelligently. Chatbots and customer support. Ever chatted with a bot on a website? NLP powers these bots to understand your queries and provide helpful responses. Language translation. Tools like Google Translate use NLP to translate text and speech between languages. Content recommendation platforms like YouTube, Netflix, and Spotify analyze what you've written or searched for to recommend content you'll love. Spam filters. Email services like Gmail use NLP to detect spam and filter it out of your inbox. Sentiment analysis. Companies use NLP to analyze customer reviews, social media posts, and feedback to understand how people feel about their products. Healthcare. NLP is used to analyze medical records, summarize patient data, and even assist in diagnosing diseases. These are just a few examples, but the possibilities are endless. NLP is truly transforming the way we interact with technology. Challenges of NLP. Of course, NLP isn't perfect, and there are some big challenges it still faces. Ambiguity. Human language is full of ambiguity. For example, the sentence "I saw her duck" could mean you saw her pet duck, or that she ducked to avoid something. Machines struggle to figure out the correct meaning. Context. Understanding context is hard for machines. For example, the word bat could mean a flying mammal or a baseball bat, depending on the sentence. Sarcasm and humor. Machines often miss sarcasm or humor because they rely on literal meanings. For example, "Oh great, another traffic jam" might be interpreted as positive, WH, and it's actually negative. Bias in data NLP models can inherit biases from the data they're trained on. For example, if a dataset contains stereotypes, the model might unintentionally reinforce them. Multilingual challenges. While NLP has made great strides in English, it still struggles with less common languages or dialects. Privacy concerns. NLP systems often require large amounts of data, which raises concerns about how that data is collected and used. Despite these challenges, researchers are constantly working to improve NLP and make it more accurate, fair, and secure. The future of NLP. The future of NLP is incredibly exciting. Here are some trends to watch out for. Multilingual NLP. Future models will be able to understand and translate between hundreds of languages, making communication truly global. Real-time translation. Imagine wearing a device that translates conversations in real time, like something out of a sci-fi movie. Emotion recognition. NLP systems will get better at understanding emotions, making interactions more human-like. Personalized AI. Future NLP systems will adapt to your unique way of speaking or writing, making them feel even more personal. Ethical NLP. Researchers are working on reducing bias and ensuring that NLP systems are fair and inclusive. The possibilities are endless, and I can't wait to see what the future holds for NLP. NLP is one of the most exciting areas of AI because it's all about communication, something we humans do every day. From voice assistants to language translation, it's changing the way we interact with technology and with each other. What's your favorite NLP-powered tool or app? Or is there something you wish NLP could do better? I'd love to hear your thoughts. Feel free to share them with me. In the next episode, we'll explore another fascinating topic: AI ethics. We'll dive into the good, the bad, and the controversial side of AI. You won't want to miss it. Until then, keep dreaming, keep learning, and stay curious. This is Manoj, signing off.